Next, let's consider a stress element of arbitrary shape cut from the beam. So in the previous case, we tried to account for all the region above the level that we concern. So for example, we have y and the y2. Then we account all the region above the level of y. But in this case, we only take a tiny piece of area, and it is an arbitrary shape. It is not like this, okay? We are not accounting all the area above the level of y. Instead, we try to account some region above the level of y, and we observe the horizontal shear force, the two direct stresses on the left hand side and the right hand side, and the force equilibrium stuff. So still, we only consider the horizontal forces exerting on the stress element. For this stress element, it looks like this. Hope that you can feel comfortable with this drawing. The stress element looks like this. It has a distribution of F1 as well as a distribution of F2. At the same time, at the bottom of this stress element, there is also a horizontal shear force, delta H. I hope this drawing is acceptable to you. So we only consider those horizontal force components. Then we get delta H plus delta C minus delta D, dA equals to 0. Consequently, by very similar derivation process, we can get delta H equals to VQ divided by I times delta X. So the derivation is rather similar to what we introduced before. So still left to you as an exercise. It is very, very similar. If we try to divide both sides by delta X, then the left hand side will become the shear flow, and the right hand side is VQ divided by I. So still, you might wonder, why am I teaching you the same thing? So just now, I taught you what is the concept of shear flow. The equation was Q equals to VQ divided by I, but here you teach this formula Q equals to VQ divided by I again. Why? It is because there is some new meaning in the letter Q. The letter Q here is the first moment of inertia of the shattered area, which is the arbitrary region above the position of y only. So in the previous section still, we talked about the first moment of inertia for the entire region above y, but this time we don't consider the entire region. We just consider an arbitrary region, say A, like this. So in this case, the shear flow formula is still work, and we can also adopt this formula to solve some problems.